So last day we started looking at slightly more complicated expressions. So now we have more than one power going on. And we looked at the very first rule. It's like, hey, what happens if you have two powers being multiplied? And there's a rule. They're saying as long as the bases are the same, all we have to do is add up the exponents. So we had 3 to the exponent 7, 3 times 3 to the exponent 2. Together, they make 3 to the exponent 9, which makes sense because when we do the repeated multiplication, all we're doing is counting how many 3s there are. We have 7 3s here, 2 3s here, all together we have 9 3s. Right? And the one tricky situation was this one over here is when your base doesn't have an exponent. Yeah. No problem. So when your base doesn't have an exponent, there's an imaginary 1 there. Because there's 1 6 there. So altogether, we have 2 6s here, 1 6 here. Altogether, we have 3 6s. That's it. Right? So before we go on to what do we do in the dividing case, let's just practice your calculator. So if you have your calculator, pull it out. Try calculating all of these. And I'm not going to ask for answers or something. I'll just put up the answer. Just practice it. Make sure you can get your calculator to work properly. Right? So I'm going to write this down. 128, 256. 216. Okay. As you're practicing, you can look up on the screen, double check your answer, so make sure you're using your calculator properly, right? Now notice, on the very last question, I wrote down an answer. We wrote down it's not possible to do a single power because the bases were different, but it still has a value. We still can calculate what it is. We just can't write it as a single power. So here, I did the calculation. So I figured out what the first power was. 3 to the exponent 2 is 9. And I figured out what the second power was. 2 to the exponent 3 is 8. And I just multiplied those two numbers together. So it still does have a value, even though we can't write it as a single power. All right? Hopefully that makes sense. Does that make sense, everyone? Right? All right. The calculator working out well, right? So just remembering which one's your exponent button on your calculator, how to do it, right? All right. So give you a couple more seconds here. We move on. So, let's talk about dividing. Okay. Once again, our goal is to take multiple powers and write it as a single power. And we can only do it again if the bases are the same. Now, division maybe is a little bit harder to visualize what's happening, especially when written like this. So sometimes with the division question, I like to write it as a fraction. It's a little bit easier to see what's going on. So instead of having this division symbol here, I can write down 3 over 7. Maybe I'll do it in blue. 3 over 7, 3 and 7 over 3 squared. Just like that. It's a little bit easier to see what's happening. Okay? So now, our goal is to figure out what is the shortcut. How do we go from this to a single power? And we do the same process as last time. Write down what it is. So this top on the numerator, we have 7 3s. In the denominator, we have 2 3s. So I'm going to write that out. On the top, I have 7 3s. 1, 2, 3,
4, 5, 6, 7. On the bottom, I have 2 3s. 1, 2.
Okay. So last time when we were multiplying, all we did is count how many 3s there are. Because they're all in one line, they're all multiplying. So we had, altogether we had 9. Can't quite do the same here, right? What do you think happens here? Abby? Yeah. So now, the next part I'm going to do here really depends on who your grade 8 teacher is, how much sense it's going to make. Okay? So every grade 8 teacher teaches slightly different. When I do fractions in grade 8, I try to teach it in this method. Because it's a little bit easier for grade 9 and grade 10. So if you have the same number on the top and the bottom, just wait until we do it, right? If you have the same number on the top and the bottom, they can cancel each other out. Right? They don't disappear to make 0, but they disappear to make 1. Because if you have, like, say, 5 over 5, that means 5 divided by 5. That equals 1. Right? So if you have the same number on the top and the same number on the bottom, they can cancel each other out as long as everything's being multiplied. How many of you guys have seen that before? Not very many hands. Okay. What? I know you've seen it before, Sammy. Yeah. Last year, you were in my class. All right. So here, we're going to cancel out matching numbers, and it's a 1 for 1. Not 1 3 here doesn't cancel out all the 3s here because it's 3 divided by 3. So you go 3 divided by 3 is 1. So those two can cancel each other out. Right? Then I can go pick another pair because there's more 3s left over. This 3 can cancel out with this 3. So as long as everything's being multiplied, all in the same fraction, right? You can cancel a number on the top and on the bottom. 3 divided by 3 is 1. So now whatever's left over is our remainder of our fraction. So this is what's left over. Right? So that looks like 5 3s there. 1, 2, 3, 4, 5. Okay? So we eliminated stuff from the top and bottom. I kind of showed up both ways. So if I wanted to write that as a power, what would that be? Addie? 3 to the exponent of 5. Our base is 3. We count them up. We have 5 of them. Right? So going back to our original question, our base is the same. Our exponent becomes 5. So to avoid having to do all these repeated multiplications, what's the shortcut from the original powers to the single power at the end? Gabriel?
You divide the exponent by the...
You don't divide the exponent from the other one.
You try not divide, subtract.
So you subtract. Thank you. So the rule is, you go 7 minus 2 is 5. So we subtract. So in this line here, the exponents. So when dividing, we subtract. When multiplying, we add. Notice they're opposite to each other. Multiplying and dividing are opposites. And what we do with the powers is the opposite. Multiplying, we add. Dividing, we subtract. Okay? All right. So let's practice this with a couple of questions here. All right? So with this one here, we're just going to do single power column first. Combining these together, what should the base be? What should the exponent be? All right? Right? Sammy?
The base should be 3.
Yeah?
Exponent should be 2.
Correct. So we have 4 here and a 2 here, subtracting the exponents. 4 minus 2 is 2. Okay. Next one. Right here. What should the base be? What should the exponent be? All right? Yeah. What? Are the bases the same?
No. Yeah.
Yep, they're the same. In our final answer, does the base ever change from what we started from? No. So whatever the base we started from, it's in the same base. So what's the base over here? Close, -3 with the brackets. Right? All of this is the base. Okay? What should the exponent be? 3. 10 minus 7, 3. Right? 10 minus 7 gives us a 3. Okay. Next one. What should the base be? What should the exponent be? Right? Just follow the rules. Gabriel?
Would just be 8.
The base would be 8. Correct. What about the exponent?
It wouldn't be there.
It wouldn't be there. Why wouldn't it be there?
Because it cancels.
It cancels out. And Evan? Should be 1. Why do you say it's 1? Right? So the rule is we subtract the exponents. Right? And Gabriel's thought was right. And I can see where Evan's coming from as well. Right? There shouldn't be an exponent because 2 minus 2 is 0. However, we can't leave a blank here. Right? Because if we leave a blank here, that means there's actually a 1 exponent there. Well, we don't mean 1, we mean 0. So we need to put the 0 in. Right? Okay. So, evaluating. 3 times 3 is 9. Next one, this should be 27 because we have 3 3's, but is it positive or negative? Negative, because this negative sign gets repeated 3 times. Okay. Anybody want to take a guess at the next one? Sammy?
0.
Sammy guesses 0. What do you guys think? Do you agree with Sammy? Yeah, lots of people agree. That's a very good intuition. Unfortunately, it is not correct. Try it on your calculator. Right? It's going to be 1. What? Yeah. It's like, what is that? Right? No, I'm sort of trying to do my best to explain about it. We talk about this in a future lesson. Right? All right. So now, if we go back to the original question, it's like 8 squared divided by 8 squared. Right? That's what the original question is. And 8 squared is 8 times 8, so that's 64. So you're going to go back to something you would have done in grade 7 or grade 8. Right? And what's 64 divided by 64? Is it 0 or is it 1? 1. Right? So these exponent laws do not change the value of mathematics. It's still the same number. We're just going about it a different route. Right? In fact, anything to the exponent 0 is always equal to 1. Yes, Ms. McCune.
Is there like, with this one and then the 3 over the 3, would it actually be like 1 over 1 equals 1? Like
Yeah.
That's that step there, right?
Yeah, it's like that, yeah.
Okay, just double check.
Yep.
Thank you.
That's it. Okay, so now this one, this page, or this lesson actually has a backside. So flip over the page, we'll talk about the backside. I'm throwing an extra example in there as well. Right? Now, here the question goes, here's a sample question a student was given. Where did the student make a mistake? Right? And you gotta look through it, very common kind of question, and find out where the mistake is. So before we do that, in this extra space here, I'm gonna have you write out a new question here. So let's go, say x, 6x cubed times 6 to the 5th times 6 squared over this. Okay? So make it a lot more complicated than anything we've done before. It's the question that is on the back side of this page is a little bit more complicated than what you guys did on the first side of the page. Okay? So, when we're doing these kind of questions, or almost in any situation, when we're dealing with fractions, and we're trying to clean up or simplify a fraction, the step is usually, hey, ignore the other side of the fraction and just try to clean up the denominator as much as you can. Clean up the denominator as much as you can, then compare the top and bottom. So that's usually, doesn't matter if we're talking about exponents, we're talking about fractions, doesn't matter what unit, that's usually the process we go through. Once you have a fraction, right, that's what we do. So here, okay, I'm gonna focus on the top only. So ignore the bottom. If I want to write that as a single power, what would my base be? And what should my exponent be? Right? We got 3 things this time. What do you think we do with the exponents? Add them. So now we have to not just add 2 numbers, but we're adding 3 numbers. Our base doesn't change. They're all the same. So it stays a 6. But this time we're going 3 plus 5 plus 2. What number is that? 10. So our exponent is 10. Now we do the same thing to the denominator. We ignore the top. We clean it up as a single power. What should the base be? What should the exponent be? Right? 6 and 5. The base stays the same at 6. The exponent, 4, and a little imaginary 1 there, right? So 4 and 1 makes a 5. Okay. So now that we have cleaned up the top and the bottom, right? We clean up this way. Right? So this fraction line means divide. So you're going to combine these 2 single powers. The base is going to stay the same. What should the exponent be? Are we adding or are we subtracting? Austin, subtracting. Because a fraction line means to divide. Right? So we go 10 minus 5 is 5. So you took a really super complicated one and you took it all down. So the process is clean up the top, clean up the bottom, then clean up the top and bottom together. All right. 6 to the exponent 5. Going over here. Have a quick look at this. All right. It's not necessarily in the exact same order we went through, but do you see a mistake somewhere? Sammy, do you already see it?
Yeah.
Where? What line?
It's the top one. It says 9, 6 plus 3. Wait. Never mind.
Yep. So yeah, you're 6 plus 3. That's the correct step. We usually don't show that, but that's what we do. Yes, Gabriel.
On the left, isn't it? Oh wait, never mind.
Right. So Sammy first mentioned this. We usually just do this step in our head. We don't write it down. We go 6 plus 3. We jump straight to the 9. Right. That's fine. In grade 9, expecting you to be able to do that. But is there a mistake anywhere else? Like, where do you see Austin?
Got 9 over 9 divided by 3.
9 over 9 divided by 3. Okay. Why is there an error here?
Because there's already a 9 over 9 divided by 3 right above it.
So above it is this expression here. Right? Now, typically, we would subtract the exponents, or we could evaluate each thing. But either way, they're saying the top number stays the same, and they're changing the bottom number to a 3 without changing anything else. So this and this don't really agree, right? So at this stage, the person should have said, hey, let's subtract the exponents. 9 minus 3 is 6. Then grab the calculator out and go, what is exponent 6? 9 to the exponent 6, 9 exponent 6, and I get this big number, right? 531,441, right? 531,441. That's what it should have been. Okay? And that's it. All right?